Welcome, everyone. Thank you for joining OWASP AppSec Days India Virtual Edition. I'm your host, Karan Shah, and here we are with our next session, which is going to be given by Shankar Murli and Krishna Chaitanya. And the topic is Attack Lens and AI-based visualization for Mitre attack exploration. So please welcome Shankar and Krishna. Hello, Shankar. Hello, Krishna.
Hi.
Hi, Karan.
Thank you, Karan. Hi.
Thanks.
First of all, thank you everyone for joining. Good morning, good afternoon, and good evening from wherever you are joining. Today, myself and Krishna is going to talk about Attack Lens, which is an innovative framework, as well as we made a tool out of it. So it is an AI-based visualization for Mitre attack, for exploring Mitre attack framework as a whole. So just a quick introduction about me, and then I'll hand it over to Krishna for his introduction. So my name is Shankar Murli. So I'm an associate vice president in SIOPS in Standard Chartered Bank. I have almost more than a decade of experience in various cybersecurity domains. So basically, in the offense side, I worked a lot, and now more focusing on defense side. Krishna, over to you for your introduction.
Thanks, Murli. Shankar. So basically, I'm Krishna Chaitanya. So I work with Shankar in the same organization, Standard Chartered, as a senior manager in data protection and cyber ops. And I have over like 8 years of experience in the same cybersecurity domain. And we both are basically great AI enthusiasts, and we wanted to integrate the same on the cybersecurity end. So I think, yeah, Shankar, you can start with the presentation.
Thank you, Krishna. So today in this talk, we will be covering the introduction of our framework as well as a tool that we have built. Along with that, some related works, because how it is related to most of the work that has happened before. And we also talk about methodology and design, how it is being built. Along with that, a few features and functionalities of this particular framework and tool. I'll give a demonstration. We'll give a demonstration as well, how the tool functions, so that it will help the audience to implement the same in their own stream of work. Yes, moving on. So this attack lens, we believe that most of the audience are familiar with Mitre's attack framework. Basically, ATT&CK, which stands for attackers, tactic, techniques, and common knowledge. So it is all the behaviors are being clustered in form of tactics and techniques. It has a lot of its own IDs. Mitre has released a JSON of all these techniques, but there is a lag in it. We don't have any relations between malwares, threat actors, campaigns, or tactics or techniques. That the relation of any techniques that is being tagged to few of the malwares or campaigns is missing as a whole. So we feel that the present day technologies can be used to fill this gap. So we together was exploring a lot of different tools and technologies. Finally, we come up with the knowledge graph. So basically, as you know, a graph database will have edges and nodes, which means one thing can be connected to another in certain directed way. So we thought that this particular Mitre's behavior, the attacker's behavior, can be mapped into a knowledge graph. So we built our own knowledge graph. Even though it took a lot of iterations, finally we come up with something that is really tangible, which can be integrated into any organization. So we kept that knowledge base as the base of this particular project. Then we thought, how can we integrate so that even an intermediate user can use the framework for their purpose. So we thought to take the LLMs. So since Gemini was easily integratable for our project, we took Gemini for this purpose. So we have an API connection from an UI integrated into Gemini. Later, the challenge was like, as we all know, these modern day LLMs has its own way of creating many things. It does hallucination, and the results may not be that much accurate. So recently we saw a notebook LM being released by Google, where we can add our file so that the results can be more accurate. It can process natural language as well as an accurate way of getting information. So we took that technology, which is RAG, retrieval augmented generation. So we took all the initially we took all the malwares that are related to TTPs. So these malwares and TTPs are being fed into as form of RAG embedding into LLM. So by means of a user who is able to chat with a window with a UI, actually behind the screen it can give an instruction to LLM, and the output of the LLM will be 100% accurate, which is in line with what is being defined, what we require. So here in this case, we took malware and TTPs, for example, where the output of that LLM will be more accurate what this user requires. For example, a few years before, we saw during South Korea Olympic Games, a massive cyber attack happens. So a end user or the analyst doesn't want to remember the threat actors or the malware names. They just need to type, give me the visualization for the attack that happened in South Korea, okay, or maybe Olympic destroyer during Olympic Games. Just a kind of natural language they can chat. Immediately all certain process will happen, which Krishna will explain more detail. Later the user will get an output which is a perfect visualization of all these techniques related to that malware, and even when a technique is related to another malware, that also can be visualized. So this is the ultimate aim of this particular framework, and we have developed in that manner. So some of the related works, I'll just go through some related works. As we know, there are a few things like Mitre Attack Navigator, where we can generate a heat map. So this is not a kind of a heat map or something that is equal to Mitre Navigator. It's entirely different. And also attack flow, which some of you might heard about it. So this is not an attack flow as well, where the user need to key in all those details so that they will get a visualization. So at the top, what you're seeing now is a attack graph, attack flow. At the bottom, it is screenshots of navigator, which is used for mapping certain techniques and tactics where the heat map is generated. So ours is not that, because it is dynamically generating that too, even novice user can use it. So that is the crux of this framework. So just pass on to Krishna so that he will explain the methodology design behind it. Krishna, over to you.
Yeah, thanks, Shankar. Basically, we have kept user in mind while developing this framework, which will enable a user as friendly as possible. So it will be easier for the user to give a prompt in the natural language. So there's a field that's provided for the user to give a prompt, and also we have given a customizable options where if the user is not so confident with the prompt, he or she can actually select the fields from the drop down and then give a query as well. So once the user drops in the prompt in the UI screen, so that prompt will trigger via our API integration, as mentioned by Shankar. There's an integration that has been done already with the Gemini LLM. So the query will be passed on to the LLM, and whatever the output that gets generated, it undergoes the RAG as well, because to understand it better and to generate a better accurate output, what we have done is we have created a knowledge graph based on the MITRE framework itself. There's a knowledge graph created, and the output from this LLM is being compared with the knowledge graph, and we'll generate a filtered knowledge graph. So that would be like an accurate knowledge graph. So this accurate knowledge graph, we leverage Network X and then 5S to create the final visualization chart. So that's basically whatever the graph that you are seeing on screen right now, yeah, I understand it looks like a universe, but that's the universe that's created by us with the knowledge graph. This is the knowledge graph that's created based on the Mitre data, and the whatever the output that you get from the Gemini LLM will be compared with this graph, and you will get a final visualization, which you can see in the demonstration that will be given by Shankar in the coming slides. One of the good things is the utilization of the rack, and also the unique IP of this knowledge graph. So these two are the important points within this design. So why? Because this will ensure the accuracy of the final output, and also it will ease the output. That means it will separate the threat actors, malware used, and the technique that's being used. So whatever the user wants it at the end, they can see it in an easier flow of the graph. So that's a high level methodology and design that we followed for developing this framework. And then I think you can go to the next slide for the features. Yeah. So yeah, as I mentioned in the earlier introduction itself, that we kept user in mind for developing this framework, the ease of access and the ease of prompting the query. So once the user prompts the query, uh, our end goal is to provide a easier correlation between the malware that has been used and what is the technique and who are the threat actors that has been involved in the attack. So those that's the major functionality we targeted with this attack lens framework. And also, what are the important features that we used? One is the natural language processing. As I mentioned, once user gives a prompt in as simple English as possible, or in the natural language per se, so that will be understood by the LLM, and it will create an output based on the knowledge graph that's there within the model. And dynamic visualization is the second point. So when I say dynamic, so user won't get any stored outputs or a static outputs, and whatever the user that depends on the query, and also the user will have an option to customize as well, right? So based on the query, based on the inputs that's been provided by the user, the output varies, and the output will be as tailored as per the needs of the user, and it will be pretty dynamic. The visualization will be dynamic. So on screen, you can see the one more graph, right? This is the final graph that you'll see, or the final output graph, knowledge graph that will be visible for the user at the end. So you can see that the center focal point is spread into several nodes, and there are several connections as well that are visible. So everything will be in detail shown at the time of demo. But however, this would be the how the final output would look like. And then the next feature, very important feature, is the filters. So even though the prompt feature is there, or the prompt option is there for the user, we have already given one more option for the user to give filters. So this will enable the user to customize the query further. So there will be an in-depth analysis done based on the filters that the user inputs, and this will help us to create more tailored output for the user, more tailored knowledge graph for the user. And finally, the integration. Uh, as you all are aware, the Mitre attack framework, or the database, the vast, huge database that is there. So our framework is like integrated with it, which will ensure that whatever the latest attacks that happened, or whatever the latest data that's there in the cyber attack world, that is there is leveraged, and is definitely used in developing the output. So it's not a stagnated data or old data where you get an output which is not updated and which might not be useful for the user. So as the integration is there, and as the database is updated on a regular basis with all the latest updates, even the output reflects the same. So these are the important features and functionalities with the attack lens framework. And with this, I hand over to Shankar to dwell further into the demonstration. To you, Shankar. Yeah.
Thank you, Krishna. Yeah. I'll just demonstrate the kind of things that we have done. So initially, the frame, what Krishna told, as Krishna told, we took this design as a whole, but to uh, place this whole thing into a kind of web server and make it active is a kind of challenge. So we thought to leverage some of the freewares or open source which are available in market. So finally we took Python Anywhere. So we took Flask as a as an app. So what you're seeing now is the front end of that particular realization of that tool. So as Krishna mentioned, we have few of the categories where we can select and then generate visualization, as well as the natural language way of chatting and then generate visualization. So two options are there. So these two options are given basically to make sure that in case the LLM integration doesn't work, so they can use they can directly talk to the knowledge graph from the drop down button as such. So assume that we have created few of the sample prompt. For example, so we talked about the Olympic game related malware. So I just took this. So let's assume I'm just typing as malware used against Iran nuclear power plant versus malware against South Korea Olympic Games, or we can use whatever form of entering into the prompt. So after this, when I click generate visualization, it will go through all these phases and immediately give me a visualization. So here, the beauty is like whatever techniques that are associated with malware, we don't know the malware name. So now you can see that it's Stuxnet, which is an accurate. There is we have tested in so many cases, and the result doesn't gives any hallucination or any surprises. So Stuxnet is a malware, and again, all the TTPs associated with that malware is being shown here, and those which are having relation to Olympic destroyer, that is also can be seen here. So you can see you can see what is common to both these malwares here, like lateral tool transfer, discovery, admin shares, Windows admin shares, etc., are being common to both these malwares. So that also can be explored. There is another thing we just introduced. Unfortunately, that is not being applied here. It is like you can right click and then pivot a particular particular vertex or edges. Okay, like when I need to pivot lateral tool transfer, I can also pivot and explore from there. Assume that those malwares that are using this technique can also be explored. Like from the UI itself, we can explore and dig deep into all those knowledge graph database. So that is how it is being designed. So currently it is in we are trying to make that build that, so that it will also add value to when we are exploring this from the UI. So I'll show one more example. Similarly, we can have relations of various different malwares or campaigns, event campaigns. So you can see here where the Carbonac is there, so which is related to WannaCry. So as we know, Carbonac is entirely focusing on stealing. Their objective is monetary benefit. Similarly, WannaCry is having the same. It's a ransomware operator, but they do have a common technique, which is Windows service. We can see here, which is Windows service. Similarly, when you take NRAT, okay, that is having some commonality between other malwares as well. That also we can see here. So in the right side, you can see the relation between NRAT and Carbonac. That too can also be found here. Okay. So as Krishna explained, so here you can see, you can see the UI, the workflow or the design where user gives the prompt and all the process happens, and finally we generate a visualization. Okay, so here the key is like we used PyVis and Network X, and it is being filtered. So the generated visualization again is in an HTML format, so it doesn't require any resources from the end users as well. Overall, it is very lightweight application or lightweight. The framework can be applied in any servers as we need. It's very lightweight, and the coding is also very less in nature. So I'll just go show the whole code. So if you see the total, we have around 200, less than 200 or around 200 lines of code. We have written all these things. So you can have go through this whenever you want to implement this as well. So we'll give all those links, etc., for your reference. These are some reference URLs. If you have any questions, please put it in chat. And Krishna, you want to add anything or suggest some more what we are going to do in future, all those things, anything of that sort, please.
Yeah, so one thing is, as shown by Shankar in the demo, so the visualization part is the key USP for this framework. And what we are going to develop is like make it into further layers where either you can map with actor based or malware based or attack based. So as Shankar already showed the ease of movement within the graph as well. So you can get hold of a node and then dig from there and analyze further on that as well. Like for example, now we are seeing two attack correlations where what is the commonality between the techniques or the actors, right? So once you go in depth, like you choose one of the node and then click on it, you should be able to dig further into, okay, on this actor, what are the attacks that happened, what types of attacks happened, and what is the what is the nature of the damage that happened based on the attack. Also, our I can say this is as a phase two of development, which is still under the discussion phase between myself and my friend here, Shankar. So basically, once the user identified the nature of the attack and then what is the commonality between multiple attacks, so our framework should be, I mean, our target is that the framework has to um, create a response on what can be the mitigation as well for this attack, and what can be the resolution for this attack, and how in the previous history or in different cases how this attack has been tackled. For example, in the Iranian nuclear or the Olympic attack case, so let's say the similar type of attack happens in future. I say similar, not exact. So now you develop a model, and based on the historic data, right now any model can give you the output saying that, okay, in South Korea so and so thing happened, in nuclear plant case Iran responded in this particular way. However, our target is that this AI model or the model that we are going to develop, so the framework that we are going to develop has to provide an output in such a way that the framework has to think like a human and then suggest you a way forward, which can help you to decide. It obviously it cannot replace the human intelligence at the end of the day, the emotional intelligence or the decisive power, but it can guide you. The framework can guide you further. So our vision or our aim for this framework is to help the firms or help the users to tackle these attacks, and then not give chance for these bad threat actors to have an upper hand. That's the end goal. So we want there needs to be a peace across the cyber world as well. That's the ultimate goal of this framework. Yeah, that's it. Yeah. Yeah, I'm done, Shankar. Yeah. If
Yeah,
anything you want
thank you.
to, yeah, we can go ahead.
Yeah, I just want to add something. Like as Krishna told, our future project is more on. As you see here, we are using NLP, knowledge graph, along with that visualization with networks. So in future projects, we are thinking of using the prediction power of AI. Okay, so when some kind of signals happens in the organization, with that signal how the attacker would have reached that level, and from there where he is going to do. So all these correlations we are trying to develop. So that will be on future phase, and maybe in the next two as we will be able to share it with the
Yeah.
whole audience. Thank you very much. Over to you, Karan.
All right. Thank you so much, Naveen and Shankar. This was an amazing tool that you all brought in front of us. I'm sure this tool and using AI to such an extent is definitely going to help organizations a lot. This is really, really amazing. All right. I'm sure audience has a lot of questions and they will reach out to you on socials when over your social media. And yep, thank you so much everyone for joining this session, and a big thanks to Google for sponsoring this. See you all in the next session.
Thank you.
Thank you. Thank you, everyone.